All right, here's the problem we got. 2x to the 1/4 power over 12x squared. 12x squared. We cool? And this is a good problem because it reminds you of exponential rules. Let's just deal with the numbers. Is it all right if I just write it like this? I mean, if you look at the numbers, it's 2 over 12. That's the same as 1 over 6. Right? Any questions?
Do you do anything to the exponent?
Yes. Yeah, we're going to do stuff to the exponents, but it's just 1/6. Right? That's the numbers part. Okay?
Yeah.
Okay. Do you guys remember the rule about dividing exponents? Oh, wait. Is the testy multiple choice or something? Yes. The testy is a multiple choice test, I think, for the most part. You guys all say thank goodness, but to be honest, you multiple choice tests aren't always easy. If you're a really creative jerk of a mathematician, you can come up with really good, and I tend to be really good at coming up with hard multiple choice tests, just to let you know.
But then if you get a wrong answer and it's not one of the options.
That's true. That's true. It's a good way to check your work.
Yeah.
Or it's a good way to cheat because you can work backwards sometimes, right? Okay. Anyway, the 1/6 part, we're good with that, right?
Mm-hmm.
That's just the numbers. Do you guys remember how to deal with these dividing exponents? No? All right, what if I did this, like x to the 5th power divided by x squared? What does that equal to? Do you guys know?
You just divide it like regular numbers?
Think of it, there's 5 x's on top, there's 2 x's on the bottom. Bradley's saying x cubed. Does it kind of go with your gut as far as like, oh, okay, yeah, I can do it.
So dividing exponents is just subtracting.
Dividing exponents with the same base. The base is x over here, and I can't do this if this were a y,
Oh, okay.
right? But if I have 2 exponents, one on top, one on the bottom, and they have the same base, I just subtract the exponents, right? Here, I'll give you a visual picture. This one is x divided by x. Well, if you're dividing it, this guy cancels out with that one, and that one cancels out with that one. You have x cubed left over. Cool? So I can remember the rule if I have an easier example. Right? All right, so how do we do this one? Okay, well, that's just x to the 1/4 minus 2. Yeah? I just take the exponent at the top and I minus the exponent on the bottom.
What did you do at the top?
Which
Oh,
one?
when you divided it, you take 1x out.
Yeah, like
Okay.
x5 over x squared is equal to x to the 5 minus 2, which is x to the 3.
Oh no, it's not because it's 2x over 12x and now it's just 1x.
Oh, yeah, well, that's what I
It
did.
just canceled out.
x5
Yeah.
over x2, I took into account that x2 by putting that negative exponent.
Yeah.
Cool? 1/4 minus 2. Let's do it on the side here. 8 over 4 is the same as 2. I'm just making common denominators. You learned this like in 3rd grade, how to subtract or fractions. So this is what, like negative 7/4? Okay. Cool.
Oh, do you just leave it at that?
Oh, actually, so I think one thing I can show you is, see this negative exponent? It moves things, if it's in the numerator, it moves it to the denominator and makes it positive. And if it's in the denominator and it's a negative exponent, then it moves it to the numerator. It takes the reciprocal of that.
Okay.
Is that vaguely familiar with you? So like this thing was actually 1 over 6 x to the 7/4. Because this x was in the numerator over here. So I moved them into the denominator, and I made the exponent positive to take into account the fact that I moved it. I think that's option A, isn't it? Or no, option B.
Yeah.
There we go. Option B. Any questions, comments, concerns, vomits, etc.? All right, I said I would do page 23, I think, right?
Oh yeah.
So that was a good exercise in negative exponents and all of that kind of stuff. I'll tell you what, before I do question number 23, I think question 23 is going to be completely separate. I'm going to make it a different video. Not question 23, but number 23. But let me write down the exponential rules for you, okay? You don't need to remember these, but it's good for you to at least see them. If I have x to the a divided by x to the b, that's equal to x to the a minus b. Cool? If I have x to the a, so this is one rule. Here's another rule. X to the a times x to the b, that's equal to x to the a what? Plus b. Good. I say you don't need to remember them because if you give yourself easy examples, then you can figure out all these rules. Like, for example, x5 over x3 is x to the 5 minus 3, which is x to the 2. Or, I'm sorry, in the previous example I gave, that was 2, I think. Or if I have x to the 5 times x to the 2, this is what? X to the what?
7.
7, because there's 5 x's here, and there's a times symbol in between all of them, and then there's 2 more x's over there, and so there's 7 of them all together.
Yeah.
We cool? So this is nothing freaky. And I don't even remember, I mean, yes, obviously I remember them because I just pulled them out of my head, right? But I mean, honestly, I get stuck on tests too. And what I do is I think, do I know the answer to the easier version? And then I'll write down the easier version. And I'll say, oh, I remember that property. Okay, let's apply that to the hard version, which included fractions, apparently. Here's another good tidbit of information. X to the negative a is equal to 1 over x to the positive a. Okay? That's that negative exponential thing that I'm doing. And you can actually see that, actually, to be honest with you, this rule comes out of this rule. Watch, I'll show you. And then you'll be like, oh my goodness, I see it. If you have x to the a times 1 over x to the b, which is exactly what I have here, okay? Then would I be able to say, that's equal to x to the a times x to the negative b? Because I took that x and I brought them upstairs, but I made it a negative exponent. Are we cool with that?
Oh, is it because
Yeah, I reciprocated him. I didn't want him downstairs. I wanted him upstairs.
Okay.
So I just changed it to a negative sign. I can always go a step backwards and make that a positive sign, but then bring him downstairs. Are we cool?
Yeah.
And then I would say, hey, wait a second. According to rule number 1, this times that is just adding those exponents. So this is just x to the a minus b. Because a plus negative b is, look, that's that rule right there.
Yeah.
Like I said, you don't need to remember the rules, but it would be good for you to at least see me put the rules up there, and then I would honestly just choose easier numbers if you forget these rules. Okay? I think the only other rule that I haven't really specifically talked about was x to the 1 over a is the same as the 8th root of x. So x to the 1/2 power is actually the square root of x. X to the 1/3 power is actually the cube root of x. Now, I think you're asking yourself, why don't we write a 2 there on the square root, right? Because if it's the 4th root, you put a 4 there.
Yeah.
it's cube root, you put a 3 there. But why don't we write a 2 there if it's the square root? I'll tell you why. Because we're too darn lazy.
Oh, is it one of those like?
It's one of those things that if it's not
default.
there, default it's a 2.
Yeah.
Got it?
Yeah.
I hope that this review of all of math of the history of the world is helping you.
You guys can come and go as you guys please. Poor Kayla over here has to stay and hang out.